Welcome to Brain Vision.
In this problem, we have a cable comprised of, let's see here, three segments in this case. So it's supported at point A and point D, and then there are loads acting on it at point B and point C. Now we have position vectors from A to B is known, so we have that it's 4 meters or 4 feet in the x direction and -7 in the y. We don't know the vertical position of point C, but its horizontal position is 9 feet. And then to point D here to the opposite end is 12 feet and then -4 feet. Now we can, let's see here, we can do free body diagram of the entire cable system here, and that means that we're going to get, let's see here, I think that should be B. So we're going to get PB plus PC plus FA plus FD has to be 0. And then we have the moments about point A, so RAB cross PB, RAC cross PC, and RAD cross FD are moments, and those have to sum to 0. We can also take a look at substructure. So if we cut this rope here and just look at the free body diagram there, we get that PB plus FA plus FBC, the load in the rope that we cut, has to be 0. And then if we take moments about C, we get RCB cross PB, okay, so this, and then RCA cross FA, and we could get RCB and RCA because we know all of these. So RCA is just minus RAC, and RCB is just RB minus RAB minus RAC. So we have, then we'll get 3 equations here, 3 equations here, and will give us some equations to find what we're looking for. And in this problem, we're looking for the tension in each segment and the total length of the cable. The tension in this segment here winds up being 46.7 pounds. In this segment, we can figure that out because this tension has to be equal and opposite to whatever this is. So if we just did a free body diagram at that point, we know that we can figure out what FBA is from FA. And that turns out to be 83 pounds. And likewise, we can figure out FCD from FD. And that turns out to be 88.1 pounds. To get the length, we just need to know what this distance here is, the horizontal position of point C, and that turns out to be 9.68 feet. And so now that we know the position of all these points, we can just find the length of each of these segments and add them up, and that turns out to be 20.16 feet.